Hi, good morning everyone. This is Jagdish, Assistant Professor of ECT Department, SNS College of Technology, Coimbatore. Today, in our subject Optical and Microwave Engineering, we are going to discuss about the topic Gunn Diode Oscillator. So, come let's get into the topic. So, before that, we have to take a look on the what is microwave semiconductor devices. So, microwave semiconductor devices include microwave diode, point contact diode, varactor diode, gun diode, impact, tripad diode, tunnel diode, microwave transistor, and MMIC. At microwave frequency, conventional transistors and diodes do not function as desired due to the following reasons. Length of the leads introduce significant inductance at microwave frequency. Then next thing, high internal capacitance, then high transient time of carriers through these devices. And diodes generally generate microwave signals anywhere from around 1 gigahertz up to frequency of possibly 100 gigahertz. Diodes are also known as transfer electron devices, that is TED. Although it is referred to as diode, the device does not possess a PN junction. Instead, the device uses an effect known as Gunn effect, named after the discovery of J.B. Gunn. Although Gunn diode is normally used for generating microwave RF signals, the Gunn diode may also be used for amplifier. In what way? In what may be the known as transfer electron amplifier or TEA. So Gunn diode or transfer electron device can be termed as a diode because it has two electrodes. Gunn diode is fabricated from a single piece of N-type semiconductor. The most common materials are gallium arsenide, gallium and indium phosphide, that is INP. The device is simply an N-type bar with N plus contacts. It is necessary to use N-type materials because the transfer electron effect is only applicable to electrons and do not holes found in a P-type material. So you can see the internal structure of Gunn diode and the symbol of Gunn diode here. Here we have two N plus and one N active layer. So the metal contacts also there. So we can see the VA characteristics of Gunn diode. So you can see the Gunn diode operation depends on the fact that it has a voltage controlled negative resistance. This being dependent upon the fact that when a voltage is placed across the device, most of the voltage appears across the inner active region. The inner region is particularly thin, and this means that the voltage gradient that exists in the region is exceedingly high. The device exhibits a negative resistance region on its VA curve. This negative resistance area enables the Gunn diode to amplify signals, enabling it to be used in amplifiers and oscillators. However, it is the Gunn diode oscillators are the most commonly used. As the field increases, the electron drift velocity in gallium arsenide reaches a peak and then decreases. As the E field increases, the energy of the electron increases and the electron can be scattered into the upper valley where the density of state effective mass is 0.55 MO. The J.B. Gunn discovered the Gunn effect in February 1962. He observed random noise-like oscillation when biasing N-type gallium arsenide samples above a certain threshold. He also found that the resistance of the samples dropped at even higher biasing condition, indicating a region of negative differential resistance. So you can see cathode, anode, and the given input is V naught. So voltage and current VA characteristics is mentioned over here. So you can see the graphical changes. So materials in which the Gunn diode effect, such as gallium arsenide, indium phosphide, gallium nitrate, must be direct band gap material that have more than one valley in the conduction band, and the effective mass and the density in the upper valley must be higher than the main valley. So it is important to note the sample had to be biased in the NDR region to produce the Gunn diode Gunn domain. So the successive formation and drift of Gunn domains through the sample leads to AC current oscillation observed at the contacts. So Gunn diode oscillator. In Gunn diode oscillator, the Gunn diode will be placed in the resonant cavity. A Gunn oscillator is comprised two major components. There is a AC bias and another one is a tuning circuit. So the tuning circuit, in the case of oscillator, the oscillation frequency primarily depends on the middle active layer of the Gunn diode. However, the resonant frequency can be tuned extremely either by the mechanical or electrical means. So the low power oscillator and microwave frequency applications are, and the another one is a radar and another one air traffic control is being used. Let us have the assessment. As so gallium arsenide is used in the fabrication of Gunn diodes because you just choose the answer. And the next question: when the electric field applied to the gallium arsenide specimen is less than the threshold electric field, the current in the material. We have four, answers options. You just choose the appropriate answer. Thank you.